All right, so today I want to start with a couple more examples of how to draw these Lewis structures. I want to start with two that are particularly difficult or a little trickier to work through, just that you've got a couple examples to look at as you start working through these Lewis structures. Now remember, we're looking at how can we best fit atoms together to make sure that every atom involved has a stable outer shell, a stable valence electron shell. And we know for most all the elements that's full octet. For just a couple of those nitrogen, however, we just have the duet, or 2 in that outer shell. Good old 1s2. So we got two examples today that we're going to look at. These are actually both located on that handout HO 6.4. So if you want to flip to this spot in your packet to be able to follow along and get another example problem, that would be awesome. First one we want to look at is N2.
Isaac Knott, please come to the front office. Isaac Knott, please come to the front office.
So for N2, nitrogen, N2, we always start, for any valence electron or valence Lewis structure, we always start by figuring out our total number of valence electrons. So find nitrogen on the periodic table, you count over to it, you'll find that each nitrogen has 5 valence electrons. Since we've got 2 of them, we've got a total of 10 electrons to work on, or 10 electrons to work with, or 10 pieces of tape to stick our Lewis structure together. So we follow through our steps. Step 1, count your valence electrons. Step 2, pick a central atom. Nitrogen or nitrogen? I hope you said nitrogen. Well, let's pick nitrogen for the central atom today. Put N right there in the middle. Right now we have it drawn, got no valence electrons. Now, step 3, connect to your outer atoms with a single bond. Remember that a single bond has 2 valence electrons, one from the first atom and one from another. We have now used 2 electrons. We're down to 8 electrons to continue building our structure. All right. Now we fill the valence shell for our outer atom. We said this first nitrogen was our central, so we look at our other nitrogen. It's got 2 in the bond chart right now. So 2, we need 3, 4, 5, 6, 7, 8 to make it stable. Well, we just used 6 more electrons. We are down to 2. Well, if we got leftovers, we put them back in the central atom. We'll go ahead and put them on this other nitrogen. And we're done. We are out of electrons. No more electrons left to use. Whoa, 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 whoa. As we look at our molecule here, you should be going, wait. We're done? Can't be done. Because our first nitrogen that we put our valence electrons on here, our outer nitrogen atom, has all 8. It's totally fine, totally stable. But if we look at the central nitrogen, we have 1, 2, 3, 4. This nitrogen is not happy. But we're out of valence electrons, which means we're going to have to do some extra sharing. We're going to have to send some electrons down into a bond. We're going to have to form a triple or a double bond depending on how many electrons we've got. So when this happens, we followed all of our steps. I think we're down to step 6 now. We're going to take, if we run out of electrons, we're going to take some electrons from the atom that's stable, that's happy. We're going to bring them down into an extra bond. Here you go, buddy. Those 2 electrons we just brought down, put into the double bond. So we can go ahead then and erase them. I would highly recommend not working in pen for this assignment. If you need another handout, let me know. I'll come and get you one, and you'll have an extra one. Okay. So as you look at that first nitrogen that we just stole a couple electrons from, 2, 4, 6, 8, still stable. Our other nitrogen now has 2, 4, 6. So close, but no cigar. So we're going to take 2 more. Bring them down, drop them into the bond. Here we go, buddy. Do a little extra sharing. When we do that, our first nitrogen here is still stable. 2, 4, 6 in the bond, 8 in that lone pair. Check the other guy, 2, 4, 6, 8. Everybody's happy, everybody wins. We used a total of 2, 4, 6, 8, 10 electrons, which was all we had to start with. Cool, there's our first example today. Nitrogen, diatomic element, does pair up with itself to be stable. Triple bond, very, very strong. That's why the 70-80% of the nitrogen in the air right now is okay, because it sticks together in that triple bond. Second example I want to look at today with you guys. Flip on over to page 4, very last page of our packet. Should see about 2 or 3 down on that last page there. It is CO3 2-. Now we're going to come to know this as a carbonate anion. We're not quite there yet, but this is a particle that we're going to need to know for our success here in chemistry. But we're going to start by drawing its Lewis structure. Steps are the same. Only thing that's different is that charge, which is going to affect the number of electrons. We know an ion can't change the number of protons, but you can change the number of electrons. Let's see what we got here. Carbon, 4 valence electrons on the periodic table. Each oxygen here has, count over to 6, so plus 6, plus 6, plus 6. All right, and then we come to this 2 minus. What has to happen in order to become negative? In order to do this, that means we have gained additional electrons. To have a 2 minus charge, that means we have 2 extra electrons in the molecule, in our covalently bonded molecule, giving us a 2 negative charge. 2 extra negative electrons and positive protons. So to get our total, we're going to add 2 extra. Well, if we add these up real quick, we got 10, 16, 22, 24 total electrons to stick this together. There's step 1, count your valence electrons. Step 2, pick your central atom, carbon. Carbon is a great central atom. Carbon right there in the middle. All right, we got a carbon. There's step 2. Step 3, bond your outer atoms using single bonds. Bonds, oxygen, bonds, oxygen, bonds, oxygen. That's a terrible oxygen, awful oxygen. Hold that thought, terrible oxygen, way better. Awesome, go. Got our 3 oxygens. There's step 3. Step 4, fill the valence shell for the outer atoms. Right now, each oxygen has 2 electrons. So to become a stable octet, we got to fill in 6 more. 1, 2, 3, 4, 5, 6. We're going to do that for all of them. 1, 2, 3, 4, 5, 6. We just use 6, 12, 18, 19, 20, 21, 22, 23, 24. We have used all 24 electrons by the time we have reached step 4. Whoop, 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 whoop. All right, well, let's double check. All of our oxygens have 8. Those are good. Step 5, we need to make that central atom stable. If we had leftovers, we put them on there. If we don't, so we go to step 6. If we are short, we're going to form some double and triple bonds. Well, as we look, carbon only has 2, 4, 6 electrons in those bonds being shared with it. Which means we're going to have to form a double bond. Now, it does not matter which oxygen we pull our electrons from. Doesn't matter. We're just going to pick one, and we're going to pull 2 of those electrons down and put them into that double bond. Here you go, buddy. When we do this, that oxygen gets to retain a valence shell, because it now has 2, 4 in the bond, 6, 8 in those lone pairs. But carbon now has 2, 4, 6, and 8. Gets to be stable as well. Now, for full completeness, for this anion to be completely correct, we've got to show that this structure is charged. To do that, we're going to go ahead, put brackets around the whole thing, and show that it's got a 2 minus charge. Okay. Now we fill out those last 2 columns that we've been practicing. If you go back to that first one, you're going to see an Na and Na, because there really isn't a central atom here. Either one could be considered the central atom. For this second example here, we've got carbon, we've got 3 atoms, 1, 2, 3 atoms in the center, and no lone pairs on that carbon. Cool. Your homework is posted on Blackboard. To follow along on that Blackboard agenda, and we'll be back tomorrow. Have a great day.